The elements of the periodic table.
There's hydrogen and helium, then lithium, beryllium, boron, carbon everywhere, nitrogen all through the air with oxygen. So
Hi, I'm Chandani.
I'm Deepthi.
I'm Leo.
And I'm Vandana.
And we are Group 15.
Mom, Dad, I can't fall asleep.
Oh no! What should we do?
No sleep? Don't weep. I got you, peep. Have you heard this drug is dope? You don't have to hope. With this biogenic amine, you can sleep clean. Thank God for chemistry, because now you have glee. So no more groaning. You got melatonin.
Melatonin?
Let me show you. Melatonin is a biogenic amine that's commonly found in animals and plants. In mammals, melatonin is produced by the pineal gland, which is found right there. In humans, melatonin is a hormone naturally produced by our body to regulate our sleeps. The synthesis of melatonin is triggered by the darkness. Therefore, at night, our body synthesizes an increased amount of melatonin. Similarly, light causes a decrease in synthesis of melatonin, causes us to wake up. However, for some people who don't produce the same amount of melatonin, we need a variety of pills and drugs for different reasons, such as insomnia, jet lag, or delayed sleep phase syndromes. Let's look at the molecule, which is C13H16N2O2. And then the IUPAC name of melatonin is N25-methoxy-1H-indo-3-ethyl. There are different functional groups in melatonin, such as the carbonyl group, amine, or aromatic rings. And so let's look at the IR graph of the melatonin. As you can see, there's a peak at about 3,300, which is the amine group, and there's little peaks at about 3,000, which indicates the sp2 and sp3 of CH. There's also a peak at 1,700, which indicates the carbonyl groups. For the next graph, which is mass spectroscopy, there's a high peak at 233, which is the molecular weight of melatonin, and there's also a peak at 234, which is the isotope of melatonin. For the next graph, is the HNMR of melatonin. As you can see over here, there's a peak at 7, which indicates there's aromatic rings and amide RCON groups, which match with the group of melatonin. And there's also a peak at 2, which indicates the group of R2NCH and R2NH, which indicates in the melatonin groups up top there.
Thank God for our instructor, because now we know the structure.
But how is this made?
Let us see the synthesis you really can't miss this.
Biologically, there's only one pathway of making melatonin, and that starts with tryptophan, in the presence of an amino acid that we're going to call L-AAAD. So what happens is the L-AAAD reacts with the 5 position of the tryptophan, and it adds a hydroxy group here, which in turn creates the 5-hydroxytryptophan. And then again, in the presence of the same amino acid, the amino acid reacts with the alpha location of the 5-hydroxytryptophan, and it pulls away the carboxylic acid. And that results in the creation of serotonin. And here, 2 separate steps are happening, where initially the histamine pulls the hydrogen away from serotonin, and then now the electrons that were initially in between nitrogen and hydrogen react with this acetyl-CoA, which is a universal acetyl donor, in a process step called nucleophilic acetyl substitution. That results in this molecule where now the O wants to create a double bond here, so the electrons here move, creating a double bond which influences the acetyl-CoA to leave. And then in the presence of this biogenic amine, the acetyl-CoA grabs the hydrogen so it's able to stabilize itself, which causes the biogenic amine to become negative. And in order to get rid of that negative, the biogenic amine grabs a hydrogen from this compound, which finally results in this. And then here, again, different biogenic amine comes into play, and that grabs a hydrogen from here. And then that causes the electrons here to move on to the oxygen, which creates a negative charge. And then because of this negative charge, this compound is motivated to grab the positive from the CH3, which is part of the S-adenosyl met, which we also term SAM, which is also present during this reaction in our bodies. And then the negative charge is able to pull away the CH3, which is a good leaving group, and then that finally creates melatonin.
But where do these pills come from?
Where do they come from? Let me tell you, chum.
So, there are a lot of people like Deepthi that cannot sleep very readily and need an external source of melatonin to help them out. Because of this, they found a way in 1968 to synthesize melatonin in the laboratory. Since then, there have been various methods to create melatonin. However, this is still the most common and most efficient way to create the pill we find in drugstores today. So let's get started. We start out with 5-methoxyindoles-3-acetonitrile. And let's call this part of the compound R. From there, we add common materials that are used for reduction, such as sodium and ethanol. So the electron from sodium attacks the 5-methoxyindole-3-acetonitrile at this position here to move the electrons to nitrogen and create the double bond instead of the triple bond. From here, we have a radical that is formed with a charge on the end. And the charge is not ideal, so that is why ethanol is added in order for a proton transfer to occur from ethanol to the N-. From there, the radical is still present, but the charge is now gone. This process repeats itself, so another electron is added to the radical to create a negative charge. Another proton transfer occurs to shift it to this, and then an electron and ethanol are added again to reduce this double bond to a single bond. And this process repeats one more time, and we end up here. This is the amine that is created from the original cyanide present. The next step in the laboratory synthesis is to add acetic anhydride. And what this does is it gives something for the amine to attack, and with this attacking, it will rearrange, and essentially the acetic anhydride will split. From there, we now have this compound where the N has a positive charge and is now attached to carbonyl, and then we have the negatively charged compound here, which is this half of the acetic anhydride. From then, naturally, the negative will attack and grab this proton, and these electrons will go here to get rid of the negative charge. And from that, we have melatonin and a side product of acetic acid.
After what my parents said, I need to give melatonin a try.
Eight hours later.
That was a great night's sleep thanks to melatonin. However, melatonin is not the only hormone that affects our sleep. Let me explain. Cortisol is another type of hormone found in our body that also affects our sleep. Cortisol is a stress hormone, and this operates on the opposite cycle as melatonin. It decreases just before you go to bed and it increases when you wake up. However, if a person experiences high level of stress and has high level of cortisol in your body throughout the day, the level never decreases. Therefore, the two hormones become misaligned, and this causes you to stay awake. Another hormone that affects our body is adenosine. It is a byproduct of energy consumption by the body. As it accumulates throughout the day, we start feeling tired and sleepy, which alongside with melatonin makes you fall asleep. Due to the similarity structures between caffeine and adenosine, caffeine replaces adenosine in the brain receptors. For example, the heterocyclic aromatic amines are found in both caffeine and in adenosine. This is why caffeine keeps you awake and prevents the production of adenosine in the body.
Wow, Dee can sleep without counting any sheep. So like I said before, now we know for sure, with this melatonin, there ain't no more groaning.